Welcome to my channel once again. This is Teacher Tari. In our previous lesson, we treated questions on the practical chemistry on how to solve the problem associated with titration problem. So the much awaited question actually came up on the 20th of this month, that is on Tuesday. So I'm sure some of you were able to solve this problem because most of these parameters we are asked to solve, we actually treated them here. So in today's aspect of this work, we are going to solve this practical chemistry 2025 so that we'll know our strength and weakness. And as for those that is going for alternative B, this will be as a form of a practice for them to know one or two issues that will come up during the examination. So in this aspect, as I've said, the questions go this way. This is a practical chemistry question 2025, alternative A. So in this video, we'll try as much as possible to solve each of these parameters that we are asked to solve so that we'll know our strength and weakness. So in this now, the question go this way. You say A was prepared by dissolving 0.825 gram of HCl in 250 centimeter cube of water. Say B contains 4.0 gram of impure sodium hydrogen trioxocarbonate per 250 centimeter cube of solution. We say calculate one of them A, concentration of solution A in mole per dm cube. 2, concentration of solution B in mole per dm cube. 3, concentration of solution B in gram per dm cube. 4, we're asked to calculate for percentage purity of sodium hydrogen trioxocarbonate. So most of these parameters we are asked to calculate. We are able to solve these problems during our practice questions. So in this aspect, you are now asked to solve for concentration of solution A in mole per dm cube. As I've said before now, that each of these titration questions, if you should see a question that do not come with the mole per dm cube, if the molarity, which is the molarity, if the molarity of the acid or base is not given to us, we'll be able to derive the concentration using a different formula. Instead of using Ca Va all over Cb, Cb Vb equals to Na all over Nb. We cannot use that formula to solve the problem because none of this concentration of the A or that of the B is given to us. And if you can see, all of this is given in centimeter cube. It says 0.825 gram of HCl in 250 cm cube. And as I've said, for us to know the mass concentration of this solution, we must compare to 1000 centimeter cube, which is in dm cube. That is to say, as I've said before now, that for us to have this problem solved, I'm going to use this formula: mass concentration. So in mass concentration, we say the unit of mass concentration is given in gram per dm cube. So all of these must be converted to dm cube. That is to say, if this is dissolved in 250 centimeter cube, we must compare when it is dissolved in 1000 centimeter cube. That is to say, each of these parameters, the A and the B, is given, they were dissolved in 250 cm cube. So we must convert them to dm cube. How can we convert this to dm cube? We say we use a very simple relationship. We said one of the steps we are going to look at today for easy understanding, I'm going to solve the solution. Let's solve for A. We said 0.825 gram of HCl in 250 dm cube. Okay, that is to say whatever we are looking for should be at the right hand side. We say if 250 cm cube of HCl contains 0.825 gram. How much more is 1000 cm cube? So that we'll convert it to what? To dm cube. We say this will give us S. So that we know the mass concentration of this solution in gram per dm cube, we must convert it to gram per dm cube. So we are going to make a relationship. This will cross multiply, this will come this way. So we are going to have 250 cm cube times S is equals to 0.825 gram per 100 cm cube times 100 cm cube. That is to say, for S to be on its own, we divide both sides by 250. So divide both sides by 250 cm cube. That is to say, 250 cm cube all over 250 cm cube. Here we said we have S here is equal to 0.825 gram times 1000 cm cube all over 250 cm cube. So here we want to know the gram per dm cube of this. So by so doing, let's use 0.825 times 1000. We're having 825 divided by 250. That is to say, divided by 250, got 3.3 gram per dm cube now of HCl. So for us to dissolve, to convert it to a dm cube, we said 3.3 gram of this HCl must be what? Dissolved in 1 dm cube. That is to say, 3.3 gram is a gram per dm cube of HCl. So if you are able to know the mass concentration of HCl, we'll be able to use the formula known as mass conc equals to molarity times molar mass. So since we know the molar mass of HCl, given the relative atomic mass of each of them, let's have the relative atomic mass of hydrogen is 1, chlorine is 35.5. That is to say, we can actually look for the concentration of A easily. Let's wipe this. That is to say, we can say mass concentration in gram per dm cube is equals to molarity mole per dm cube times molar mass, 3.3 gram per dm cube of HCl, okay? Time molar mass. Molar mass is given a gram per mole. So if we should have this, we'll be able, since we noted that where mass is equals to 3.3 gram per dm cube. So that is to say, and the molar mass of HCl, we said hydrogen, the relative atomic mass of hydrogen is 1. It occurred only once, plus relative atomic mass of chlorine is 35.5. It occurred once, that is 35.5. That is 1 times 1 plus 35.5. We have 36.5. Since this parameter is available, we can look for mass conc. Okay, that is mass conc, that is 3.3 gram per dm cube is equal to the molarity, which is the concentration of this A, which is HCl, of this HCl times molar mass is 36.5. This is gram per mole. So since now we can divide both sides by 35.5, divide both sides by 36.5, I mean, mole, gram per what? Per mole. By so doing, we said 33.3 gram per dm cube divided by 36.5 gram per mole is equal to molarity of HCl times 36.5 gram per mole all over 36.5 gram per mole. So this cancel this. If this you go, we're going to have molarity. We're going to have molarity of HCl in mole per dm cube is giving us 33 gram per dm cube divided by 36.5 gram per mole. Gram cancel gram. So by so doing, 3.3 divided by 36.5. Here we said the concentration of A is giving us 0.09090 mole per dm cube. So this is the concentration of A, because we are able to convert the value that is given to us in centimeter cube to 1 dm cube for us to obtain the mass concentration of this A. Then since we are able to get the concentration of A, we'll be able to use the concentration of A to obtain B by using CA, BA, CB, VB all over N equals to NA all over NB. Since one of the concentration is known now, that is to say, we're going to use CA, VA, CB, VB is equals to NA all over NB. So in this aspect, we're going to use the volume of acid, which is your titer value. We're going to use 23.20 cm cube. So the volume of pipette we use, we are using 25 from the beginning, 25 cm cube as well. That is to say, where CA is equal to 0.090 mole per dm cube, VA is equals to 23.20, CB, we are looking for CB, which is concentration of B. We are looking for the concentration of B. Now, we are done with this. Concentration of B, we are going to look VB. VB is the pipette, as I've said, pipette. So we have the NA, the mole ratio of the acid is 1, NB is equals to 1 as well. So let's substitute the value. We are going to have 0.090 times 23.20 all over CB times VB is 25 is equals to 1 all over 1. So in this, I'm going to cross multiply. Let's cross multiply in this. So if we should cross multiply CB, we're going to have CB times 25 is equal times 1 is equal to 0.090 times 23.20. So by so doing, for CB to be on its own, divide both sides by 25 times 1. Divide both sides by 25 times 1. I'm going to have CB times 25 times 1 divided by 25 times 1 is equals to 0.090 times 23.20 divided by 25 times 1. So by so doing, we can have this. So doing, we can have this. We said this and this will go. That is CB is equal to 0.090 times 23.20 is 2.088 divided by 25. So we're going to divide it by 25. Is CB, which is the concentration of B, is equal to 0.084 mole per dm cube. So this is the concentration of B. Since we are able to obtain the concentration of B and that of A, this is for A, the one of B is 0.084 mole per dm cube of B. Since we are able to know the concentration of A or B, we can know the mass concentration of this B by using the simple formula known as mass conc equals to molarity times molar mass. We can able to solve for this. So we are going to solve for concentration of solution B in gram per mole. This is, since we are able to have these values, so we can be able to solve for this. We say mass conc. This is I mass conc. That is mass conc. Gram per dm cube is equals to molarity times molar mass. So mass concentration of B, that's what I'm looking for. That is in gram per dm cube. I'm looking for this gram per dm cube, as I've said before. So in this aspect, the molarity of base is given as 0.084 mole per dm cube times, what is the molar mass of sodium hydrogen triacylcarbonate 4? We said the relative atomic mass of sodium is 23. It occurred once, 1 times 23, plus hydrogen occurred once, has a relative atomic mass of this. Have this, plus carbon occurred once, relative atomic mass of 12, plus oxygen occurred 3 times, relative atomic mass of 16. Here we have 23 plus 1 plus 12 plus 48. This 24, we are going to have 84 gram per mole. So in this one, we are going to have 84 gram per mole. So that is to say, this is giving us gram per dm cube of B will now be given as 0.084 times 84. We have the mass of this is 1.056 gram of this, gram per dm cube of B. So they say the next question, they say percentage purity of sodium hydrogen triacylcarbonate 4. Percentage purity of sodium hydrogen triacylcarbonate 4. If you check this, how can we know the concentration of this? This is a pure. Since we are able to use the concentration to multiply this molar mass, this is a pure sample. So in this aspect, how can we percentage purity of sodium hydrogen triacylcarbonate 4? How can we get this? Look at this now. We said if B contains 4.0 gram of impure sodium hydrogen triacylcarbonate per 250 dm cube. Okay, let's look for this mass. The mass of impure sodium hydrogen triacylcarbonate 4 in 1 dm cube. See, let's make the relationship as well. If 4.0 gram of this impure is found in 250 cm cube, we are going to compare this very easily. I'm going to compare this very easily by doing a very simple relationship. That is to say, if we should have this, let's solve for the concentration of this impure sodium hydrogen triacylcarbonate 4. We said 250 cm cube of impure sodium hydrogen triacylcarbonate 4 contains 4.0 gram. So how much more is 1000 cm cube? Want to know the gram of this impure impure in one DM cube. That is to say, we have S. These are going to have something like this. We're going to have, when they cross multiply, we say S times 250 cm cube is equal to 4 times 1000 cm cube. For S to be on its own, let's have the mass gram per DM cube of pure sodium hydrogen triazocarbonate. We are going to have a 7.056 so that we can have enough space to solve. In this now, we're going to have a divide both sides by 250 cm cube. So we are going to have S times 250 cm cube divided by 250 cm cube is equal to 4 times 1000 cm cube all over 250 cm cube. So this will go. So by so doing, we have 4000 divided by 250. We have divided by 250. We have that is 16 gram per DM cube of impure sodium hydrogen triazocarbonate. So if we should have the value of this impure, we also gotten the volume of this pure. We can actually know the percentage purity of this sodium hydrogen triazocarbonate for easily by knowing the concentration of this impure given from this. So we compare to 1 DM cube. Here we multiply the concentration of this sodium hydrogen triazocarbonate for. We believe that is the pure aspect or the pure part of this sodium hydrogen triazocarbonate 4 that participated in chemical reaction. By so doing, by multiplying the molarity, which is the concentration of this B, times the molar mass, which is 84. So the impure is given from the question. So by so doing, since we have the two values, we can say pure, the mass of pure, we say percentage purity is given a mass of pure sodium hydrogen triazocarbonate 3, carbonate 4, divided by mass of impure of same compound. That is to say, we're going to have pure is 7.056 divided by 16 times 100 times 100. That is to say 7.056 times divided by 16 times 100. So we have 44.1% of this. So thank you for watching. This is a practical chemistry alternative A solution. So please, if you should like this video, share and comment on any aspect of this calculation that is not well clear, so that I can emphasize through the comment section. Thank you.